recording. All right, so this will get uploaded to YouTube. I think I finally worked out all the bugs. What we're going to start with is just a little very brief tutorial on GitHub. Then we're going to walk through what you're expected to do in the lab. Then there'll be a link that's sent out to everybody and posted up on the board. You'll click on the link and you can do the lab. It should not take you the whole 2 hours. So, open board. On all of these machines that are right in front of you, if you go into Visual Studio and you click on File, Open, there will be an option to open from GitHub. That is not going to be on your home machines. If you want it on your personal machines, you have to go to visualstudio.github.com and you click on the blue button, you run the thingy, you get the option to open from GitHub. This is not strictly necessary. There's enough Git stuff built into Visual Studio that you can kind of make it work, but this makes it a lot simpler. Every project that I assign to you from now on is going to start with some sample code that you're going to work from. So you're going to go File, Open from GitHub. It will probably not pop up like it's about to here. It already knows who I am. I've already logged in with my credentials. First time you do it, you'll be asked to type in your GitHub username and password. Again, if you don't have a GitHub username and password, you should get one of those post haste. There's two options up at the top, URL and GitHub. GitHub is going to bring me up to a list of things. Now I have tons of repos and it's only going to get larger. So what I'm going to do is I'm going to filter for now to the thing that I want to show you. You click on this and you click clone. And I guess with the word clone, I need to talk a little bit about GitHub. GitHub is a distributed version control system with a Y, system. It keeps track of all the different versions of your software. Now, when I say version, I'm referring to incremental steps along your development process. The very first version is an empty repository, has nothing in it. Then maybe you write one feature. That's another version. So just like you go through first drafts in an English paper, this is multiple versions. And you can almost think of it as a tree. You start with the first version, then you get the next version, and you get the next version, on and on until you complete your project. We'll say it's completed, if software can ever be complete. What makes GitHub interesting is that it all lives, that's the cloud. GitHub.com is a cloud service. Git, by itself, that is the set of tools that keeps track of the versions. Okay? Has anybody ever accidentally deleted their project or lost work? Okay. Git, as a tool, allows you to, at any time, so say you're here and you've totally destroyed your project. It allows you to go back to some point in the past and get that version before you totally messed it up. Professor, it worked last night. Okay, go back to the commit from last night. Each one of these dots is a snapshot in time that's called a commit. A commit is a snapshot. Okay. Now, this is barely scratching the surface of what Git can do. This is the base of what it gives you. How many people are familiar with Git at a larger level? Okay. So there are ways to do group projects with multiple contributors contributing to the same file at the same time. your final project will be a group project, and there will be additional things you'll want to do. Some of the things that I can mention, if we think of your code as a series of time snapshots, okay, like this, that's one linear path. What Git also allows you to do is start from here. So maybe this was release version 1.0. That's your first release. Rather than polluting what they call the main branch, you can create a copy of this and start making parallel commits. Again, snapshots in time. So these parallel commits have nothing to do with your main branch. And then what you'll do, so say we have many more commits here. Okay, we can then merge those commits, and that's the keyword, merge. Merge those commits into the existing code. Takes a little bit of effort, there's some stuff involved, but it allows you to do collaboration very easily. So you've got linear snapshots in time. You can have branches. Okay, so maybe after you released version 1, you got some feedback from your users and you decided you really wanted this new feature. You would create a feature branch. And all you would be doing is trying to go from version 1 and add that feature. Meanwhile, other people are working on other features at the other time, but everybody is based around that version 1. Then everybody merges their commits back in, and you release version 2.0. This is a much more realistic way of doing software development than I'm going to wait till 11 o'clock on a Friday night, write my code, grab some stuff from Stack Overflow, shove that in, and then submit it. And then I'm done. It's an iterative cycle where you have multiple releases. So you are going to start with an existing repository. There's a link you're going to click on. It's going to create an existing repository that you have access to via github.com. This is an example repository. It's called First Program because it's your first lab. You click on it, and you're going to clone it. Again, this is another GitHub or a Git term. Clone means you take what's on the cloud and you copy it to your local machine. Okay? So in the cloud, there will be some number of commits. Then you will take all those commits, you'll dump them on your machine. You'll make some changes, but that won't be reflected in GitHub. It'll just be on your local machine. You will then push those changes to the remote repository. So the average life cycle is clone, make changes, make a commit, where commit is a keyword, clone is a keyword. After you make a commit, you'll run some tests, and we'll get to tests. Then, depending on if those tests pass, you might come back up, make more changes, make more commits. When you feel it is appropriate, you will then push your commits up to github.com. Okay? Pushing is sending to the cloud. Commits happen locally. So here I've got my project that I am about to clone. Make sure it goes somewhere where you are not going to lose it. Okay? In this case, it's going to my document /source /repo /ECE264 spring 19 /first program. Okay, clone. When you clone it, you don't actually get a solution right off the bat. You do get a Team Explorer window. It's called the Team Explorer window because generally if you're using Git, you're working in a team. Right now, you're working on your own. And it comes up with the Solution Explorer, just like we're used to from other courses, but it doesn't automatically open a solution. It gives you files. So it's important that you open the solution. Okay. Now, this solution actually comes with a, let's go to Git here for a second. Comes with a README file. The README file is a description of what you need to do. So when I went. So this is the web interface for github.com. You're going to be interfacing to github.com through Visual Studio most of the time, but there's nothing stopping you from coming over here and looking at it. In fact, you should be always looking at this when you're submitting to make sure that things have really happened. So this is the interface. There's a README associated with it. It says, okay, this is what you got to do, how to run tests, how to use GitHub. This is your first project, along with a list of commits. So the first 3 commits are from me. Any commit you make is saved forever. So don't ever put passwords in GitHub. That's a poor plan. So this is the web interface. This is the Visual Studio interface. And if I open up first program.cs, I actually have a program that's ready to run. Well, sort of. If I run this, it compiles. I don't think I'll ever give you a program that doesn't compile. There are some warnings, and then it will run. In this case, it's just asking for 2 numbers, and then it's going to crash. It's going to totally die, burn in a fire. But it's going to burn in a fire in a way that maybe is helpful. Not implemented. Return true if the number x is even, false if x is odd, because those are the functions you need to write. Exercise 3.1, 3.2, 3, and 9 in the book. Okay, and I've given you a little short description of what you need to do. So the first thing I want you to try, just so to get you into the habit of this software development cycle, is I'm just going to comment out those lines that make the whole thing crash. I'm just going to return false every time. It won't crash this time. So I can run this now. And if I type 0, 0, it tells me that the number 0 is not even, not divisible by 5 and 7. The third digit is not 7. And the 0.00 is inside of a circle. Except it's not. It's false. None of these are correct implementations for these functions. Okay? That brings us to the third thing. This is the new thing, and it's a helpful thing. There is a set of tools in Visual Studio 2013 called Test. If I go up to Test, there's an option to run all tests. I have already created some tests for you. If I go ahead and run these tests, we're going to see some output. It's going to build the project. And rather than typing things into the command prompt, it's going to force feed some values into this. It's going to, okay, run test started. It's taking its own sweet time. Okay, tons of output here. Most of them are saying you totally failed. It totally does not work. The way you look at the output from this a little bit easier is through the Test Explorer, which you can get to from Test, Windows, Test Explorer. If you open this up, there are 4 sets of tests that I've given you. For example, if I open up even, odd, that's the first exercise. Is the number even or odd? You can see that some of these tests have passed and some of them have failed. When I gave you -1, is -1 even or odd? Odd. You returned false, or I returned. My function returned false, because that's all it is. It's always returning false. It's gone. Okay, so by luck, this one passed because it said that -1 was false. -2 should have been true, but it got false, so it didn't pass. That's how you look at these tests. Okay. The advice I give you in the README is every time you try to do one of these things, before you run the tests, make a commit. Then run the tests. Then, if you need to make changes, make another commit, run the tests. And then go on, once you've gotten those tests to pass, to the next assignment. Okay? I do read this. I didn't write it just because I felt like it. It's there to help you, along with a little bit more about what's required. Let's briefly talk about ways to get a 0 on an assignment. Okay? Quickest way to get a 0 on an assignment is to edit the test file. Okay? There's no secrets here. Every test you pass in this project gets you 10 points. Okay? Every test for you gets you 10 points. Another 10 points. If you change this to say something stupid like +25, you just get a big 0. Okay? And any commit you make is saved forever. You will always be able to see anything. I will always be able to see anything you've ever committed to this repository. If you accidentally make a change, come to me immediately so that you don't get penalized. Because one of the things that's automated about this, I'm going to look at it and compare this file to the original file. And if there's ever any changes, you just get a 0. There, you are one lab of 3. There's 70 of you. Okay, so a lot of this is going to be automated. But you can see in here all the test data that I'm going to give you. Okay, I imagine that when it comes to being inside of a circle, you're going to have some tests that fail even if you have a reasonably correct implementation. And it's not written down anywhere, it's not documented how certain things should behave except in the tests. So there's no secrets here. You're going to know what tests you passed, what tests you failed, and if you're happy with enough tests passing, you can submit it, and you're done. So let's quickly go through the workflow of this. I'm going to, I'm just going to commit this. This is wrong. In fact, actually, I'm not going to commit this because this is the sample. I'm going to walk through how you commit it. So over in the Team Explorer, this is your main interface to communicate with github.com. I have made some changes, and if I click on the changes, it brings up the changes dialog blocks. The main options are changes and sync. Those are the two things we care about, changes and sync. So anytime I make some changes before I run some tests, I'm going to type a commit message. I removed the throw exception lines and returned false for everything. Okay? Make it a commit message that future you is going to find useful. Okay? This is a How I Met Your Mother thing, right? That's a problem for future Ben. Future Ben is going to want this commit message to be useful. When you are done, you're going to hit commit all, because we're not going to get into staging some changes and not another. It will list all the changes, and if you double click on it here in the changes window, you're going to get two windows that come up, and you're going to see what has changed. And this is truly powerful. It's a diff. We deleted this line and added this line. We changed it so that that was commented out. You can always track your changes. So this is like Word document track your changes, but every time you commit, you get these diffs. So you can see I changed 4 things. And up at the top, you see it says diff at the top. We don't need that anymore. Team Explorer. So I'm going to commit all. The important thing right now is this has not been submitted for grading. This is still only on your local machine. It has not changed. In order to change it, I have to sync my changes with the server. If you go to sync, it will show you all of the commits that you have to sync. So right now there's only one might have dozens. Remember, a commit is just a snapshot in time. So you will then push all of those commits. The reason I haven't given you the link and the reason I'm not doing this is because every time I do this, it triggers the grader, which takes about 2 minutes. So when you all click on this link, the grader is going to be gridlocked for roughly an hour. Okay, which is why I haven't given it to you yet. The grader is going to run the same tests that you run. Your grade is based on how many tests you pass in the Test Explorer. So, in summary, keywords. Clone brings it locally. Commit, snapshot in time. Push sends it to the remote repository for grading. It's also another way of doing an off-site backup. If your computer dies, if the whole file server in the university dies, if you've pushed it to the remote GitHub, you can clone it to a completely new machine. Okay? So here, there is a PowerPoint on how to do all of these steps. Okay? Page by page that Keith put together for us. Clicking on things, joining the roster, creating the repository. We've gone through most of that and how to actually go ahead and do this. At the end of this, if you want to check and make sure that you have pushed this and submitted this correctly, that's what this lab is all about, making sure that this all works for you, because this is the GitHub submission thing as opposed to let's do some programming. Okay? Any questions? No questions? There's a question. Yes? The name of the PowerPoint, it's in /admin. And it's the only PowerPoint there. It's called GitHub intro.ppx. Okay. So that's the end of this video. The rest of this is go to work. Oh my God, how do I turn off these notifications?